Hello, I'm John Handrick, Senior Technical Writer for Walroo. Today I'm going to be doing a demonstration of Walroo 2023.3.0 and its edge deployment feature. What this lets you do is take a Walroo pipeline where you set up your ML model, deployed it, and tested against some inference data, and then publish that pipeline in a containerized form to an OCI registry. That OCI registry is pre-configured in the Walroo instance, so when the data scientist gives the publish method, it knows exactly where to put that pipeline. Later on, we can switch over to the DevOps engineer side of things. You can tell that when I put on the DevOps engineer hat. As the DevOps engineer, I then take that published pipeline, pull it down from the OCI registry. I can then deploy it and perform the same kind of inferences that I did from the Walroo instance. So let's start off as the data scientist and go ahead and get that pipeline published. For this demonstration, I'm going to be using a pre-trained Onyx model that has been trained to detect mitochondria from images of cells. So what we're going to be doing is uploading this model into the Walroo instance, deploying it into a pipeline. We're going to be setting a pipeline configuration based on what the edge device specs will be, and then running some sample inferences. So let's go ahead and start that off. So you can see here my Visual Studio Code screen. First thing we're going to do is we're going to import in our libraries, including the Walroo SDK. I'm then going to be authenticating to my Walroo instance. I've already done that earlier, so I'm set. I'm then going to be setting up some variables that will determine my workspace, my pipeline, and my model. And my model is sitting out here in my models directory. All right, I've got some helper methods here. And from here, I'm now going to get my Walroo workspace, and then I'm going to be setting up my pipeline. For full information on this, feel free to check out the Walroo documentation site. That's at docs.walroo.ai, and you can also find a copy of this tutorial there once 2023.0 is released. Now let's go ahead and upload our model. Excellent, uploaded. Now we're going to be setting up a deployment configuration for our pipeline. So we've been told as a data scientist that we're going to have access to 4 CPUs and about 8 gigabytes of RAM. Should be more than enough for our situation. So when we deploy our pipeline, what we're going to be doing is adding in our model as a model step, and then deploying it using this deployment configuration. We'll go ahead and start that now. This usually takes anywhere from 30 to 45 seconds, but it may be faster than that. There we go, 13 seconds, not bad. All right, we can check the status. We see it's running. Everything is good to go. All right, we've got some helper methods here that are going to help us along. I'm not going to go into those because that's not the focus of this. But what they do is they take the image, they convert that image into a NumPy array, and then put that into a data frame that then we can then submit to the Walroo pipeline. So this function here just grabs all that. It takes our pipeline, it converts that image into our tensor, puts it through our inference, and then it draws a picture based on that. So if we actually run this, what we're going to do is we're going to add in those data frames and select 10 random images, convert them into our NumPy array, put them in the data frame, and I'm going to save it here to this random patches array so we can use them later on with the DevOps personality. So let's go ahead and do that now. All right, so we're now grabbing 10 random images. We're then converting them into data frames, and then we're going to display them. So you'll see the original image, you'll see the ground mass, the repository of truth, and then what the model predicts here. So there we go. So we can see this whole process took about 15 seconds, give or take. So here's the original image. We can see what the ground truth is, and then we can see the machine learning model got pretty close. We can scroll down and see the other results from there. The ground truth, predicted mass. All right. As a data scientist, this is looking pretty good to me. I can always go back and retrain this model to get even more accuracy, but for now, let's assume that I am happy with this, and I wanted to publish this. So now I'm going to publish it, and I'm going to do so with that same deployment configuration. So when the DevOps engineer takes this container, they already have the specs to use for deployment. They can edit that, they can add more or less CPUs depending on how they do things, but at least that's been included. So I'm going to go ahead and send that out now using the pipeline publish command. And I'll save it here to this variable and show that off. So it is now taking that pipeline, is containerizing it, and now is going to push that to that OCI registry. In this case, this is in GitHub, so that way I can easily reach it and do whatever I want with it later on. All right, I know it says it can take up to 600 seconds, but I'm going to, there we are, we're done. So let's go through this real quick. So this is the version of the pipeline that we have published, so we can know exactly what was sent out there. We see that it was published, that's fine. This is the engine, the part that actually does the inferencing. Here's our pipeline, which contains our model steps, and other deployment information. This is a Helm chart. So if we wanted to, we could use this Helm chart and the version to deploy this item using Helm into a Kubernetes environment. In my case, I'm just going to use Docker later on when I'm the DevOps engineer, but for now, this is fine. We see our engine configuration, and we see there was this handsome devil who did it, and then we go on. We can also list all the pipelines in this Walrus instance and see which ones have been published and which ones have not. There we go. So we can see here's all the pipelines that are out there. Our Edge Biolabs pipeline, we see that it was published. This one was published. We can see this one has not yet been published for whatever reasons. We can also list all the publishes from this pipeline. Now, I've gone through this process a couple times in preparation of this, but I can see all of the publishes, all the times this pipeline was containerized and what version it was. So we can see this version of the pipeline was published on this date, and here's the information for it. So the DevOps engineers have different versions of this pipeline they can select from depending on what is going on. All right, with that, as the data scientist, my work is done. I'm going to undeploy this pipeline, and then I'm going to switch over to the DevOps engineer situation, and then we're actually going to deploy it on an edge device, and we'll get into that in just a moment. All right, I'm now in my DevOps persona, and what I'm going to be doing is I'm going to be deploying that same pipeline that was published by the data scientist and taking that and putting that onto my edge device. So I've got a sample little function here that let me build a Docker Compose file. So I'll just go ahead and grab that real quick. This is going to take the engine URL that we got from our published pipeline earlier and the pipeline URL, which is what I actually need. I'm going to have it with 4 CPUs, and then I'm going to be adding in my OCI registry information from there. So let's go ahead and grab that. So that's how that looks. So if you give me a moment, I'm going to go and add that into my edge device. All right, I've got my Docker Compose file ready. Let's go ahead and bring it up. And I'll show that here on the screen here real quick by shifting over. And there you are. You should be able to see that now. So go Docker Compose up. All right, there we go. It's now grabbing our pipeline information, and we are good to go. Here's our model. That's the SHA for the original file, and we know it's a runtime of Unix. All right. Just for those who are curious, let me bring up the specs of this machine just so you can see what we're running at. This is an Ubuntu 2022.4. This is on a Xeon processor. So you can see the details here. We have 64 gigabytes of RAM. And then let me put the processor information up there. All right, so we're on a Xeon E5 2680. So roughly 10 years old. I've got 12 cores on this machine, so that seems to be pretty well. All right, we've got our situation published. Let's go ahead and go back to our notebook, and we can see some things. So when a Walrus pipeline is deployed on the edge, we can use some of the endpoints to see what's going on. So we can check the pipelines. In this case, we just have the one, and we see it's running, and there's our pipeline there. We can check the models. This will give us similar information. So there's our model name, the SHA for its file, the version, and other information. So with that, let's go ahead and do some inferences. So the inferences are on the pipeline name endpoint. We can submit arrow tables. We can submit pandas record format in JSON, or just regular JSON. We're going to be doing this in pandas record format. So just like before, when we had deployed our Walrus pipeline, we're going to be taking those same images, converting them over into NumPy arrays, putting them into data frames, and this time, instead of using the Walrus SDK on a deployed pipeline, we're going to be using the Python request library and submitting them into our deployed instance. Now in my case, that is over in a machine that I've called testboy, and it's running on port 80 that we deployed on. So we're set to go. Let's go ahead and run this, and we should have similar results. Get rid of that. All right, it's now taken it, turn those images into data frames, and there we go. We're almost done. Oh, about 12 seconds. So as we can see, the similar results. The image, the ground truth, and then what the model predicted. So now, I, as the DevOps engineer, can take this and deploy this into any number of machines that I want. I can put this and attach it to every edge device attached to an image scanner, so people can get those images and see directly what those mitochondria are, or take the data and do other things with it, like count up how many there are in a total set or the like. But this is deploying on the edge with Wallaroo. If you'd like to learn more, feel free to check out the Wallaroo documentation site at docs.wallaroo.ai. We also have links to notebooks just like this with sample model and images so that you can try it out for yourself. And if you want Wallaroo, we have a free community version that you can go check out. We'll put the links in the description field. So again, I'm John Handrick, Senior Technical Writer for Wallaroo. And whether you're a data scientist or a DevOps engineer, happy coding.